Hey everybody, it is December 19th, 2019. Time is 15:24 CST. It's 41 degrees Fahrenheit out, and it is Geo-Rant time, number 117. Today, what I'm going to talk to you about, this is not going to tie into that geophiles episode I've been talking about, but we are going to apply principles of geology in order to get actual thicknesses of strata. Okay, now when you're getting actual thicknesses of strata, usually lava flows, sedimentary units, things like that, because batholiths, stocks, plutons like that are a whole monster in and of themselves, and I'm not going to talk about those here. You can also get dikes this way, all right? But when we're talking about thickness, and somebody asked me to do this, it was a good question. At first I was like, why are they asking this? I'm like, oh yeah, I guess it makes sense. After they explain themselves. When we talk about thickness of units in geology, we are talking about as thick as the unit was as it was originally deposited in an undeformed manner. All right, you don't have to go pre-lithification, but if it was deposited horizontally and it's still that way, this is easy. All right, and that's what we're going to do with here first. As you can see here from this card, you always measure your thickness. In order to get a total thickness of a unit, you need to have it bounded below and above by another unit. Otherwise, you can just give an estimate or what is not eroded or what is exposed. All right, you have to mention that. But this is like this one is bounded, so we can get a thickness. It doesn't really change. This we cannot because we do not have the bottom exposed. We do not, so we have a greater than 60 feet here. Okay, so the thickness, you might be like, oh, this is easy. Well, you always measure the thickness too, as if it was undeformed and in the direction of younging. This dike is a special case, and I'm going to get to that here. But all these horizontal layers are not special cases. You measure them, you can get an actual thickness where they're bounded above and below in the younging direction. So as you can see here, this is in feet. If you're uncomfortable with that, pretend it's meters. This is a demonstration. It's not going to change the scale or anything. It'll just change the units, not the numbers. Okay, so, yeah, 60 feet there, 10.6 for the yellow, 4.2 for the green. And as you can see here, I have these two. They're not lithostratigraphically the same, but they are chronostratigraphically equivalent. What that means, you're going to see this again, so I'm not going to go over this again. What that means is two different lithologies from the dark to light blue, yet the bottom of both of these units were deposited at the same time, as were any points of equal separation between them. Okay, these are undeformed. So I can measure the thickness here and the thickness here, and I can get a range of, like on the light blue, it's greater than 4.4. And here it's less than 83. So if I put the two side by side on my strat column, because they're chronostratigraphically equivalent, I can just say it's 4.4 to 8.3 feet thick. Okay? So I can do that. That's the way I'm. Now the dike, 4.5 feet thick, but it's this way. What? Okay. Dikes are a special case because it takes time to deposit sediments. Okay? Dike essentially is a snapshot in geologic time, deposited instantly. Okay, there are exceptions to this, but essentially that's what they are. Okay, so when we're talking about thicknesses of dikes, we're actually talking about widths. We're not talking about this length. Even if we rotate it like this, we're not talking about length, because this obviously top's been eroded, and this could continue all the way down in the mantle for all we know, or grade slowly into a much more massive body. Okay, or it might be tabular or something like that. Okay, because remember, dikes are not subject to the law of superposition. Okay, they're intrusions. So we measure the width. So if you see in the literature like a dike is 4.5 feet or 4.5 meters thick, we mean it's the width essentially. And we're assuming that we're looking along strike here because our north is towards me. Okay, and I even have a measurement for the measurement on the dike of north-south strike and dipping 75 east this way. Okay, now if we have a parent, I mean, that comes in handy when you're actually trying to figure out actual thicknesses of dikes, which are real common in the Archean and Ontario, and I've done it before. But anyway, before I digress, let's get into something a little more messy. Wow, okay, nothing here, practically nothing here is undeformed. All right, we have an anticline here. This is our approximate axis. We have a reverse fault here as indicated by our arrows. Once again, everything's in feet, 100 feet. Pretend it's meters if you're uncomfortable with that. Oh, wait, yeah, 100 feet. Pretend it's in meters if you're uncomfortable with that. Okay, so just get a good look at this. The colored units, like if you see on the other side of the fault, you see yellow and yellow, that's the same unit, all right? You color in a geologic map, you always color the exact same lithostratigraphic unit, the exact same color throughout the geologic map. You do not change colors because you cross a fault, okay? You only change colors if there's lithostratigraphic change, like in the case of the blue here, okay? And we went from light blue to dark blue, kind of similar to what was before. So remember what I said. This is a little more complicated, but you can do this. All right, you need to pick sections to get thickness from that are bound above and below. Okay, like the red one here, we have green below it, yellow above. All right, in a Younging direction. Where's Younging here? All right, this is going to vary for across our cross section. In this cross section, Younging on this side is essentially up, like it was for this. Okay, but you get here, up is towards the axis of the anticline, all right? But you won't be able to get thickness from that. And in tight folds like this, things tend to thicken at noses. This is a nose, okay? We're not gonna measure from here, okay? And when I flip this, you're gonna see the numbers with the measurements, and you'll see thick red circles with X's in them that are not good places to measure actual thickness, because when you're reporting the thickness of these units, you're reporting them, the thicknesses as if they're undeformed. And the reason why we do that is so we can understand the geologic history a lot better. There's no point in reporting an isolated deformed thickness unless there's a specific reason to do so. Okay, because obviously this is localized right here in this anticline, okay? So I am going to show you the units, all right? Their thicknesses are in feet in red. Where you see the red circles and X's, those are not good places to do this. Now there's a couple of things here. I've already gone over this here, so I'm not going to do it again. But here you see this black basalt sill, and you'll see these black numbers have units. That's because I generated a column for you with the thicknesses, which I'm going to get into here in a minute. All right, so you can have geologic units pinch in and out. We know this is a sill because it's baked above and below. Okay, cross beds in this orange here, you do not measure the cross beds, all these little lines here. Let's go back to the undeformed part. You look at this here, you see all these little cross beds like here. This is bedding, all right? Bed sets also follow bedding. The individual cross beds do not. And these cross beds, this little section right here, if we undeform it, it was like this, and now some of these crossbeds have been overturned. Crossbeds really only, in something like this, a general thickness of a stratigraphic unit, they're not worth very much. They're good for determining upstream direction or upwind direction, and that's about it. Okay, so you can guess a source area. All right, you can't tell you how far it was transported. It can only tell you the direction it came from. Okay. So you don't measure from the cross beds, which are what these two X's here are. You measure from here, okay? And I hope you can see the numbers. I'll give you a second to look at this, to take a screenshot if you need to. If you see here, we cannot get a thickness of the green because the bottom, we don't have enough information. We can get a minimum thickness. That's why it says greater than 78. And here we have a similar problem. The entire thing has been eroded to some extent. We do not have a conformable unbounded layer on top. We have an unconformity here. So we can't measure that here, but we got it over here, and there's no reason to assume it's not the same thickness here. We don't have reason to think that because the thicknesses in this area, even with the fault and the anticline, unless it's in the axis or the nose, is pretty consistent, okay? Here, same thing. We can only say it's greater than 100 feet because we don't have the top. Now, we have this unit here, this white, this number 10. This is likely a superficial, relatively recent deposit. So we measure from the thinnest and the thickest, and we can get a range. Okay, so just absorb that for a second. I'm going to get to the cross section with you here, if I can find where I put it. Okay, all right. So, like I said, with the unit number 1, which is our green, we can only get a greater than because the bottom is not exposed, okay? The bottom of the green isn't exposed. So our number 2, which is our, we'll just say it's a basalt. It's a sill, okay? We have 0 to 24 feet. You can put 0 to 24. That is fine. It's a range. It does pinch out. Okay, your number 2 pinches out. Your 3, which is the red, varies from about 40 to 43 feet. We're undeformed. You could measure this in 2 places. It's okay to measure this way here because this is your younging and it's not deformed. Here, this is your direction of younging. So we got 40 to 43 feet. That's fine. Okay, unit 4, we got about approximately 120. That's our yellow. Why approximately? Because we only could get one data point of undeformed sequence bound above and below. Okay, so yeah, that's our only place. So it's about 120 feet, and the other units are thick, are about consistent in thickness. We could have put plus or minus 5 or plus or minus 10, but I personally don't do that because I have no way of actually knowing that unless I have information from outside the area to support that. All right, same thing with unit 5, approximately 60 feet, our orange with the cross beds, because we could only really measure it from one place as well. Our unit 6, we have, oh crap, our unit 6 is our brown. We had 2 good points we could do that from, our brown unit, and so we can get a range in our cross section, 70 to 71 feet. You generally leave off half feet when you do this. And when you're doing meters, you generally, like if it's 10 meters, 10 and a half, or 11 meters. It depends on the scale you're using. If you're using a unit that's 500 meters thick or 1700 feet, you don't, I mean, you don't need to be meticulous down to, half a meter or a full foot. Anyway, all right, units 7 and 8. Here, the blue, just like in our horizontal last one I showed you, it's a similar situation. We can measure the tongues, but we can measure the total thickness here. Here, we can measure the thickness of the light blue plus our thickness of the dark blue to get a similar, so we can get a range. So in our strat column, we would do this, and we have 68 to 75 feet. Our number 9, which is our purple unit, is greater than 100. I've already shown you that. And our white unit, same thing. We have a range of 25 to 60 feet. Okay. Whew, that was a lot. I hope you could absorb that. Oh, let me show this here for you just real quick, so you just screenshot it if you want. So anyway, I hope you could absorb all of that. You can see what I wrote at the top. Okay, which was your thickness. Thicknesses are measured from the undeformed position. They are also measured in the direction of younging, and if they are bounded above and below by units, they don't have to be conformable, but generally it helps. I mean, if there's a gradation or minor unconformity, you can ignore it. But something like this is kind of a big unconformity. So, outside the map area, you probably have a better thickness. So you don't want to just say it's 100 feet thick, Anyway, that's it. If any questions or comments below, please leave them. And I hope you learned something.